Hi, ladies and gentlemen. Last lesson of the chapter. So we recall that Miss Skokin claims that she is an 80% free throw shooter. Mr. Sack is skeptical and believes that she is less than 80% free throw shooter. So Miss Skokin has decided to take another simple random sample of 53 throws to prove herself. Write down the appropriate hypotheses for the significance test. Be sure to define the parameter of interest. The null hypothesis is, just as it was before, p is equal to 0.80, and the alternative hypothesis is p is less than 0.80, and we still continue to define where p is the true proportion of free throw shots Miss Skokin makes. Now, let's just decode that. We remember that if the null hypothesis is true, then that means Miss Skokin is not exaggerating and she's telling the truth. And the alternative hypothesis is that Miss Skokin is exaggerating. We talked a little bit about errors, the type 1 and type 2 errors, and so what would a type 2 error be in this setting? Let's just remember what our box says. When we have a type 2 error, we have failed to reject a false null hypothesis. So that means that Miss Skokin is less than an 80% free throw shooter, but we decide that she's telling the truth. Suppose that Miss Skokin's true free throw percentage is actually 66%, and that means that the null hypothesis would be true, that the alternative hypothesis would be true. Enter all the information into the applet shown and click to display a type 2 error. It will show up as a blue shaded region. So here are the settings that we put in. The actual null hypothesis is 0.80. The alternative hypothesis is in the less than direction. We clicked on type 2 error and we gave the true value of the population proportion as 0.66. And we had a sample size of 50 free throws. You can see this blue shaded area is what we ended up having as our probability of a type 2 error. And it's given, let's see if I can find the pen here. Okay, it's given as 24%. Now, you'll notice something else, and that is the power. That's not something that we've talked about before. But I do want you to notice that if the null hypothesis is true, what would be the probability of a good decision here? So this power idea, and I'm gonna delete this photo in just a minute and get back to our notes, but power is the probability of correctly rejecting. And this is the probability that's indicated with the happy face in the upper right-hand quadrant of the box that we drew. Let's go back to our notes now. So what we did is we used a very specific true alternative value. And we found that if the alternative hypothesis is true, that it is 66%, what is the probability of a type 2 error? We found that that was 24%. And what would be the probability of a good decision or correctly rejecting or power? That's going to be 76%. Now notice that these two are complements of one another. So the probability of a type 2 error, which we called beta, plus power equals 1. So complements. And this is the probability of type 2. This is what we call power. So we want to be able to interpret the probability of this good or correct decision in the context of the question. So we would say if Miss Skokin is actually a 66% free throw shooter, there is a 76% probability that we correctly decide that she was exaggerating and reject the null hypothesis. Okay. So we're going to go back to the applet in a minute, and what I would like for you to do is increase the power of the test. How could we adjust each of the following factors if we want to increase the power? So you're going to use the applet, you're going to try it out, and then respond to the A, B, and C questions under number 4. And then if you want to, I'm going to copy in a picture of you can draw it in or you can copy it in, take a screenshot of it so that you can see what it looks like, that idea of what happens when you have that increase in the power. All right, see you back in a minute. So we used the applet to vary these different values, and what we found was that when we varied the sample size, increasing the sample size gave us a larger power, or a greater probability of correctly rejecting the null hypothesis. And that's because, if you remember, when we increase the sample size, our variability of the sampling distribution will decrease. That decreased variability decreases the overlap between our curve of the true P and the hypothesis P. And so our power increased to 94%, which was a big increase because it was 76% when our sample size was 50. When we changed the alpha level, we saw that increasing alpha from 0.05 to 0.10 increased the power to 84%. And it makes sense because it makes it easier to reject the null hypothesis. So if it's a higher probability, it means we have a higher probability of correctly rejecting the null hypothesis. Then the last thing that we altered was the true alternative p-value, proportion value, And we saw that when we had, in this case, because we're on the left-hand side, it's a less than alternative hypothesis. When we had a smaller proportion, true proportion, and that increased the difference or the distance from the null hypothesis value that we used of 0.80. So I decreased from 0.66 to 0.60, and that made the power go up to 94%. So it makes us more likely that we will correctly reject the null hypothesis. So power is a big thing, and in a nutshell, to increase power, we can either increase our sample size, increase our alpha, or we can increase the distance between the true alternative and the null hypothesis. All right, let's move on to the box of important information. We're revisiting that box that crosses the truth with the conclusion that we draw. And this is going to be important, so please remember it. And we have something slightly different in the upper right-hand corner. Instead of having just another smiley face, knowing that we correctly rejected, now we know that the probability of us doing that is the power. And so we have written in power. And just as a reminder, we know that the probability of making that type 1 error, this is the way that we think of it, is alpha, and the probability of making a type 2 error is beta, which can also be thought of as the complement of power. Let's fill in the other side now. And you probably guessed it, this is going to be all about power, which is the probability that we reject the null hypothesis given that the alternative hypothesis is true. So it's when we reject the null hypothesis when we should, because the alternative hypothesis is true. And the way that we would interpret this is, if the alternative hypothesis is true, and that means that the alternative hypothesis is true at a specific value in the context of the question. So if that alternative hypothesis is true, then there is and this is where the power comes in, whatever the power is, probability of finding convincing evidence to reject the null, again, in context. And just as a reminder, once again, if we want to increase the power of the problem, there are three things that we can do. One of them is to increase the sample size. Another one is to increase alpha. And the last one is to increase the distance between the null hypothesis and the true alternative hypothesis. Okay, that is our box. Now, the next item is you're going to work on the check your understanding, and then turn the video back on when you're ready to check your answer. I know that sometimes you feel a little bit reluctant to do these without supervision, but you can do it. Get through as much of it as you can, fill in whatever you can, really think it through, and then turn on the video to check your answers. So I'll see you back in a minute. Okay, hopefully you were able to come up with the correct answers for each of these, but if you didn't, go ahead and copy down this information into your notes, and that means we are done with this chapter, with the notes in this chapter. So I'll see you back in class for test review.